I want you to listen carefully, and we will have a complete revision by next week.
Okay.
I will just give you the principles here. It will not, we don't have enough time. Okay, so this is now the column from the bottom to the top. It is a packed column. Inside it is a cylindrical plastic material. Packing material. What kind of packing material is this? What type?
والله ما ادري.
What type of packing material is this? Huh? It is a plastic cylindrical material. What type? I said you are finished with you have started with absorption. This is a reishi green.
didn't mention on the theory.
Reishi green.
Reishi Greek?
Rashid.
Russian.
Okay.
We know the saddle, but we don't
You have the saddle. We don't have saddle.
Ah.
Okay. This is a reishi green. And from the top, water will be flowing down the column.
Okay.
From the bottom, gases will enter, air and carbon dioxide rising up the column.
Okay.
Below is the entry point of gases. So the concentration of gases is more than at this point. Meaning, as the gases rise up the column, the concentration decreases.
Okay.
Because simply this is the entry point more of gases.
Yes.
Now, this is the tank where water will come from. This is the valve so that the water will be moving and circulated in the system. Water is moved using the centrifugal pump. Water will pass through the eye of the impeller. The impeller will help move the liquid going up
To
the
this-
column using a flow meter.
flow meter.
It will measure the flow rate
From the back.
and then it will go up the column. Okay.
Teacher, first question. Why the bulb goes to the distillation column? For the absorb
to the bottom.
Yes,
From the
which one?
bottom.
This one.
Recirculation.
Cycle
okay.
goes back to the tank. and from the
Okay,
tank-
now, with the aid of a compressor, air will be moved and air will pass through here, passes through a flow meter to measure how fast or how the flow rate of the water is. And then it goes down and pass through the bottom of the column. Likewise, if we have carbon dioxide will pass through F3, the flow rate for carbon dioxide. It goes at the back and mix with water, and then together they will pass through the bottom of your column. Okay, C4 is the valve that is used for circulating water. F1, the flow rate for water as calibrated in liters per minute. F2 is for air calibrated in liters per minute. F3 for carbon dioxide, also in liters per minute. If you notice, these kinds of valves are operated either counterclockwise or clockwise. This one also, and also with this. If you open the valves of this type, you are operating it or opening it counterclockwise or anti-clockwise if you want that term, or to the left. So fully open, I will move to the left. If close, to the right. Okay. So 1, 2, 3, 4. We have 4 valves similar with similar operation. Plus 2 for on-off switch. 0 means off, 1 means on. This is the selector pointer. So if you want to put it on, up. If you want to put it on, up. Don't put it down. During the finals, I will be having a 1 meter stick. If you put it down, I will just tap your hand.
Okay.
What happened if you
Which
put it
why is
You
two?
will damage the switch.
And that's will get zero.
Why teacher the design of this one like this?
Huh?
It's confusing. Why
I don't know.
You mean it goes down? Easy.
If you put it down, it will not go down.
Okay, so
No, some students are forcing them to put it down. That's why I have that stick. Tap the hand.
Okay.
Okay, now how many switches? How many valves? 1,
4.
2, 3, 4, and a valve switch,
2 switch.
5, and 6.
Okay.
Okay, Now let us go to the three-way valves. 1, 2, 3, 4, 5. 5 three-way valves. The three-way valves. The three-way valve is very, very easy to understand.
Okay.
Let us try to focus at this three-way valve. These are handles where it indicates the flow. If the handle is situated here, there is flow, there is pipeline. If this black handle is situated here or position here, there is flow, there is pipeline. The handle here, there is flow, but there is no pipeline. So it does not flow here, right? On top, there is no passageway, there is no flow because there is no handle to indicate the flow. It is black, it is closed. So it will not pass through or it will not go up. This situation, let us see. 1, 2, 3, three-way valves, so we have 3 handles. If the handle is positioned in this direction, gases can pass through it because there is flow and there is pipeline.
Inlet.
This one, it may be inlet or outlet. This one, there is flow, there is pipeline. This one, there is pipeline, but it is closed, there is no hole, therefore there is no flow. This one, there is opening, there is flow, but no pipeline, nothing will be moved. Okay. Now, another one is the inlet valve and the outlet valve. If you notice, the handle is a single handle valve. If the handle is parallel to the flow,
Open.
it is open, and if it is perpendicular to the flow, it is closed. Okay. This is where your sampling vessel is. It is measured in milliliters. You can have a sample of 10 milli using this reference line. You want 20, you want 40, you want 60, and so on and so forth. Okay? It is very easy, like a cylinder. And this is where you measure your vis of 1. Your vis of 1 is 20 milliliter, so therefore your sample should be 20. Okay, now I will show you later. Vis of 2 is measured at this scale. It is also in milliliters. 1 milli, 2 milli, 3 milli, 4 milli, until 8 milli. Between 1 milliliter, there are 10 graduations. Therefore, 1 graduation is equivalent to 0.1 milliliter. This is now your Hampel apparatus. It is filled with sodium hydroxide, 1 molar sodium hydroxide. How to put? Just take a pipette or plastic dropper and put it inside and then drop your sample. Okay. Making sure that this level is at 0. How to put it to 0?
Drain.
No, do not drain.
Open.
Make connection to the environment, to the air, right? So that it will be freely moving.
Push it.
And then, as soon as it is at the 0 level, you close the connection to the air, then you are ready.
It goes down.
Yes, it's open to the environment. It will flow. Okay. The same pressure. Okay?
Teacher, before I have
Now,
I think it should
wait. You are in the group, other group. These two, we have the manometer,
Yes.
pressure measuring device. We will not use this one today. It is on a different experiment. Okay, now, this is the inlet port, inlet valve. This is the outlet valve. First, before you take samples, you have to trace the flow. If I will open this one, gases will pass through here. Okay? So first, we will try to trace the flow of the gases. It will enter here, up. You should collect sample from here. Okay? It goes down to the manometer, up. This line, not the outer pipe, inner pipe. It will pass through here, but it blocks the way to the sampling vessel.
So we have to
So
open
make a way so that you can collect the sample. This one. So it will go up. It will not go down. It will not go to the left. It will go up. Note that there is a T junction here. Either the gas will pass through or go to the left or to the right. If the gas will go to the right, let us check this three-way valve. It will pass through here,
But
it will return back to the column, especially if the valve is open.
But
So it's useless. Even if it is closed, you have to have a potential closing of the valve. You have to block the gas.
Yes.
Okay, stop, and then it goes up. It will not go down, it is black. Go up, up, up. Now you are ready to take the sample.
Teacher, we don't have a valve in the conjunction right there.
No.
Why? To affect the...
This one?
Yes, here. We cannot?
No, they did not put.
But we can put...
We can put.
Oh, okay.
Yes. Now, to the outlet. Open. Then make a trace your connection. This will not go here. Instead, you make connection. The gases will pass through here to the left. It will not go up. It will not go back to the column either. Then it will go to the T junction. It will go down. Make sure that when you collect gases, it will not return back to the system. Block it.
Block it.
Then you are ready. Okay?
Teacher, before I open this valve, I should make sure the whole way is clear. Like,
You should. Before you open the inlet or the outlet, you trace.
Okay.
Because it will be useless. Your gases will just go out.
okay.
Okay? So 6, one by one, you trace the inlet and the outlet. One by one, you trace the inlet and outlet. You start.